In the last lesson, we learned that pi is the ratio between the diameter and the circumference. In this lesson, we're gonna use pi to solve problems. This is the warm-up. Here's some pictures of circular objects with measurement tools shown. The measurement tool on each picture reads as follows: wagon wheel 3 feet, plane propeller 24 inches, sliced orange 20 centimeters. For each picture, which measurement is shown? That's number 1. Number 2, based on this information, what measurements could you estimate for each picture? Pause the video and try the problem yourself. So let's take a look at the wheel first. And the wheel, which measurement is shown? That's the diameter. Diameter. And what measurements could you use to estimate for each picture? Well, that would be feet. You would use feet. Maybe 4 feet, 5 feet, depending on the wheel. So feet. You might also use meters. Meters. And what measurement would you use for the fan? Well, that's the radius. I'll use a different color. That's the radius. And you might use inches or centimeters. And how about the orange? Well, the orange, let's use green for the orange. The orange is, they're measuring circumference. Circumference. And they are using centimeters to measure the circumference of the orange. In this activity, we're going to use pi. We're going to use pi to solve problems. In the previous activity, we looked at pictures of circular objects. One measurement for each object is listed in the table. And it says I'm going to assign you an approximation for pi, but I'd like you to use pi. Just write out pi. Like that. Instead of writing 3.14, which is pi, you could write pi. Instead of writing 3.14, you could just simply write pi. So the wagon wheel, it says the diameter is 3 feet. If the diameter is 3 feet, how long is the radius? So we know the diameter is from one end of the circle to the other, and it goes through the center of the circle. Here's our circle. That's the diameter. That's the center. And our radius is half of that. The radius would be right there, is half. So the radius is half the diameter. So what's half of 3? Well, you could write it as a decimal, or you could write it as a fraction. I'm going to use fractions. I'd like us to get used to writing fractions. So half of 3 is 3 over 2. Oh, something over 2 is half. So 3 over 2 is half of 3. The radius is 3 over 2, and it's feet. It's in feet. Okay, what about the circumference? What's the circumference of the wagon wheel? Well, the circumference is, we learned in the last lesson, is pi times the diameter. That's the proportional relationship between the diameter and circumference. It's always going to be pi. How do you get to the circumference? You multiply diameter by pi. So the circumference is 3 times pi, and you could write that as 3 pi. You don't have to multiply it out. If you do iExcel, it's asking you to multiply it out, but when you show your work on tests, and when you talk about circles, you could just use the word pi. Say 3 pi. That's fine. So the circumference is 3 pi feet. Okay, let's take a look at the airplane propeller. We know the airplane propeller is 24 inches. This is either a model airplane or a very small airplane, but the airplane propeller, the radius is 24 inches. So how long is diameter? Well, we know the diameter is 2 times the radius. 2 times 24 is 48. 48 inches. Okay, now how about the circumference? Well, just like the wagon wheel, the circumference is also a circle. The airplane propeller is also a circle. So the circumference is the diameter times pi. What's the diameter? Is 48. And that's times pi. 48 pi is the circumference. And that's in inches. Let's take a look at the orange slice. We know, so the table's telling us the orange slice, the circumference is 20 centimeters. I'm going to erase this to give us more room. But we know that the circumference is 20 centimeters. So now we need to go the other way, and if we know circumference, how do we get diameter? Just think about that for a moment. How do you get diameter if you know circumference? Well, we know that diameter times pi is circumference. So let's write that. Diameter times pi is circumference. Okay, so that's our relationship between diameter and circumference. So how do you get from that? How do you get the diameter? Because we're trying to get diameter. Diameter. How do you get the diameter? Well, we can manipulate that equation. If you balance the equation and get diameter by itself, you will get how do you get diameter? So if you could divide both sides of the equation by pi, and you would get diameter. If you divide both sides of this equation by pi, you get diameter equals circumference over pi. So diameter equals circumference over pi. So go back to the orange slice. The orange slice, the circumference, the diameter is circumference over pi, 20 over pi. And you could divide that, 20 divided by 3.14, or you can simply write 20 over pi. And in higher classes like trigonometry, they simply write pi. They don't use 3.14. Okay, so now how do you get the radius? We know that the radius, I'm going to erase this up here so we have more room. We know that the radius is half of the diameter. Half the diameter. So how do you write out half of 20 over pi? Think about it for a moment. Pause the video and think about it for a moment. How do you write 20 over pi, half of that? Well, let's do it. Let's write 20 over pi. 20 over pi. I'm going to do it over here. 20 over pi. And we want half of that. So all over 2. That's saying half of it. And if you take 20 over pi and you divide it by 2, you get 20 over pi, 20 over 2 pi. That is half of 20 over pi. And you could simplify that to 10 over pi. And if that's the first time you're using pi, for a lot of us, it's probably the first time. We're writing fractions with pi, so it's a little bit more advanced than what we're used to. But you can check this. So let's check it over here on the top. 10 over pi times 2. Times 2. What's 10 over pi times 2? That is 20 over pi. What that tells us is 20 over pi is half of 20 over pi is 10 over pi. So let's write our orange slice has a radius of 10 over pi. And we just filled out the table for the wagon wheel, airplane propeller, and orange slice. A bug was sitting on the tip of the propeller blade when the propeller started to rotate. The bug held on for 5 rotations before flying away. How far did the bug travel before it flew off? So you read this, and this is quite a mouthful, right? There's a lot going on, but you can read it and break it down into the main points. So the main point is there's something on a propeller, it's a bug, and it's going around and around and around. And it says it goes around 5 times. So it goes around 5 times. 5 rotation means it goes around 5 times. So it wants to know, how far did it travel? So how far did it travel before it falls off? Well, if we go back up here, look at the airplane propeller. The diameter is 48 inches. The diameter is 48 inches. So one thing we could do is write that down. 48 inches. And so we want to know, how far did it travel before flying off? Well, the bug's at the tip of the propeller. That means if you think of the propeller as a circle, the way it spins a circle, the bug's at the edge of the circle. So it helps to draw a picture. Draw a picture with these circle problems, right? It's very geometry heavy, and when something's geometry heavy, you always want to draw pictures. So the bug's on the edge of the circle, and that's really the key point here when solving this problem. It's on the edge. And it's going around 5, so let's draw a diameter here. Let me use another color. The diameter is 48 inches. 48 inches. 48. And now we want to know, how far did the bug travel 5 rotations? So it would help to know how far it traveled for 1 rotation. How far did the bug travel for 1 rotation? And again, that's also a key point. So break down the problem. And a lot of times you want to think, how far for 1? How much for 1? That was a key point from 6th grade. How much for 1? So let's figure it out. That would be the circumference. If it goes around 1 rotation, that's the circumference. So what's the circumference of the propeller? Well, the circumference we wrote the circumference. We figured it out already. The circumference is 48 pi. So one rotation is 48 pi. Circumference, 48 pi. Okay, that's 1 rotation. So how about 5 rotations? Well, 5 rotations is 5 times the circumference. And that is 5 times 48 pi. So 5 times 48 pi. So you can leave the pi, but let's multiply the 48 out by 5. So 48 times 5. 8 times 5 is 40. And then 5 times 4 is 20. So the total distance is 240, and remember that's times pi. So let's add this into our 5 rotations. 5c is 5 times the circumference, or 5 rotations. And that's 240 pi. And you can leave that as 240 pi. So answer the question a full sentence. How far did the bug travel? The bug traveled 240 pi inches. And the lesson has an applet here, and you can rotate the bug. So if we rotate the bug 5 times, and the blade length is 24. Yeah, if the blade length is 24 inches, that means the diameter is 48. So that's our blade length. It said it was an airplane propeller, and here it's wind turbine. So I guess that changed, but just the circle is all the same. Doesn't matter what it is, but the properties of a circle is the same. So let's start turning our bug and see how far it travels. Well, it's not telling us how far it travels, but it is turning 5 times. We figured out how far it's turning. It's traveling 240 pi inches. Now let's take a look at a scenario where it's a circle, but there's also straight lines involved. So let's say you split a circle and then you add other shapes in between the two halves, such as a running track. If any of you go running, you know that a track is not a perfect circle, but if you take both sides, it makes a circle, but there's something in between those two circles. So let's take a look at our running track. Here's a running track, and it says the field inside a running track is made up of a rectangle that is 84.39 meters long and 73 meters wide, together with a half circle at each end. So that is quite a mouthful, but if you take a look at the field, the running track, you can see that it is a circle split in half with a rectangle in the middle. So I could show you that, but here's our rectangle. And it says we're using the around the inside of the field. So the green part. So there's our rectangle. And then here are our half circles. There's a half circle. So again, it helps to draw out geometry problems. Draw out the geometry problems. If you keep it in your head, you'll usually run into mistakes because you're trying to think about the shapes and the numbers, and it's really a lot to think in your head. So draw it out. Draw out the shapes to help you visualize what's going on. So the question is asking, what is the distance around the inside of the track? So we now broke up the track into different shapes. That was a 6th grade skill. You're taking a compound shape and you're breaking it up, called decomposing. We decompose the shape into smaller, simpler shapes. So you need these, how long the rectangle is, and then plus the circumference. So it says that the rectangle is 84.93. So 84.93 meters. So we're going on the track. So if you're going on the outside of the rectangle, it's 84.93 meters in each direction. And then you need to round the track. So if you round the track, that's half the circumference of the circle. So why don't we get the whole circumference of the circle? And it doesn't matter how much each one is. Let's just get the whole thing together. So how do we get the diameter? Well, if you notice, we do have the height of the circle. The height of the circle, I'll do it in green. The height of the circle is this, is 73 meters. And the height of a circle is diameter. It's the same thing as the length of a circle or the width of a circle. It's all the same thing. It's all the diameter. So the diameter is 73 meters. So the circumference of the whole circle is 73 pi. So that's the circumference of the whole circle. So on the outside of the track is 73 pi plus 2 times 84.93 and and then all that in meters. So meters. And that's the distance of the outside of the track. Do you need to multiply that all out? No, I don't need to see you multiply it all out. You could if you want and get one number, but that would be an expression showing the outside of the track. And I apologize because I said the outside of the track, but I meant the inside. It's the expression for the inside of the track, inside. Let's use our knowledge about circles to measure a picture frame. So here's our picture frame. And so take a look. What do you notice? First, what do you notice? And pause the video and think about what do you notice in terms of what shapes do you see here? What shapes do you see here? Well, there is a rectangle, but if you're trying to find how large the picture frame is on the outside of these curved bits, so these are curved. I'm trying my best to trace out the circle, but definitely not perfect. But anyway, so if you go on the outside, so how do you find how far this whole thing? If you keep doing this outside of the whole picture frame, how far will this be? So these are circles, and just like the track that we just calculated the outside of the track, so these are circles. So think about how we can use what we know about circles to think about this picture frame. And let's go down to the question. Let's see what they're asking. Kiran. So Kiran bent some wire around a rectangle to make a picture frame. The rectangle is 8 inches by 10 inches. Find the perimeter of the wire picture frame. So it's asking for the perimeter. And then it's asking if the wire picture frame were stretched out to make one complete circle, what would its radius be? Okay, so let's do one at a time. Find the perimeter of the wire picture frame. So let's go back here. And here's our picture frame. We need the perimeter. Okay, well these are circles. And let's take a look at let's do the sides first, without the corners. Take a look at the sides. So there's these half circles. We have 3 of these half circles on each top and bottom. So there's 3 half circles on the top, 3 half circles on the bottom. So there's 6 half circles altogether. 6 half circle. And now we have the corners. So the corners, there's 4 corners. 4 corners. Corner circles. And I encourage you to write out the problem just like I'm doing it. You know, look for what you notice. What are the key points? What information will help solve the problem? So write it out. 6 half circles, 4 corner circles. And let's find the perimeter of each one separately, because they're going to have different perimeters, because the half circles are half of the diameter. Okay, so let's take a look. Do we need... we didn't look at the measurements yet. Let's go down and take a look at the measurements. Okay, so the rectangle is 8 inches by 10 inches. 8 inches by 10 inches. So 8 inches is the shorter side. This is 8 inches. That's 8 inches. And this, okay, so let's do the 8 inches first. And pause the video and see if you can see, try to figure out the diameter of each circle. What's the diameter of each circle? So if you think about it just a little bit, you'll see the diameter of each circle is 2 inches. 2 inches. And I'll use orange for that, or else I'm going to run out of colors. But the diameter of each one is 2 inches. So that's 2 inches, that's 2 inches, that's 2 inches. And here is half the diameter. So that's 1 inch and 1 inch. Still, the diameter, this is the radius is 1 inches, but the diameter is 2 inches. So now how can we use that information to find the perimeter? The perimeter. Well, the perimeter of a circle is the circumference. So the circumference of each circle is 2 pi. And I will use blue for that. So the circumference of each circle is 2 pi. But these are half circles. So the circumference, this bit in green, is pi. Each one of these half circles is pi. The perimeter is pi. And how many half circles do we have around the whole frame? So we have 3 on the top, 3 on the bottom. That's on the top and bottom. And then you have another 4 on the right side and 4 on the left side. So another 8 half circles. How many is that all together? So together, we have 14 half circles. And altogether, the perimeter is of all, I'm just talking about the half circles, not the corners. We're not doing the corners yet, but that is 14 pi. So 14 pi. So now, that's the perimeter of all the half circles. Now let's do the corner circles. So there's 4 corner circles, but let's take a look at one individually. Well, the diameter, I encourage you to pause the video and just think about this before the explanation. So the diameter is 2 pi, and the circumference of the whole circle is, the diameter is 2, the circumference is 2 pi, and the circumference of 3, so that's 3/4. It's 3/4 of the whole circumference. So 3/4 times the diameter. 3/4 times the diameter, and then times pi. So think about how I got this. 3/4 2 pi. 3/4 of 2 pi. That's because the whole circumference is 2 pi. But we don't need the whole thing, we just need 3/4 of that. So 3/4 of 2 pi, and you could simplify that as 6 pi over 4, or 3 pi over 2. So each of the corners is 3 pi over 2, and we have 4 corners. So we need 4 times 3 pi over 2. And that would be 6 pi. So all of the 4 corners is 6 pi. That's the perimeter, 6 pi. 14 plus 6. The perimeter would be 14 pi plus 6 pi. And that would be 20 pi. So the total perimeter of this frame is 20 pi. The total perimeter is 20 pi. So now that we've found the total perimeter, let's go down and try to solve number 2. Let's go down and try to solve number 2. Number 2 is asking, if the wire picture frame were stretched out to make one complete circle, what would its radius be? So let's do that. Let's draw out the circle. Here's our circle. And the circumference of this circle is 20 pi. What would its radius be? Well, if the circumference is 20 pi, then we know that the circumference is the diameter times pi. So diameter is 20. Diameter is 20. And we know the radius is half the diameter. 20 divided by 2. The radius is 10. 10 inches. We're in inches. The radius is 10 inches. And so the hard part was number 1. Once you have the total perimeter, that is, if you make that into a circle, that's the circumference. And then once you know the circumference, you can find the radius. This is the lesson synthesis. And the main ideas from today's lesson are: the proportional relationship between diameter and circumference of a circle can be applied in more complex situations that require multi-step solutions. And some of these are a little bit intimidating, but if you break down the problem, draw a picture, draw out the dimensions that you know, height, base, length, write the circumference, diameter, write everything out, draw a picture, it makes it much easier to break it down. Break down the problem. And the second bullet point says, because the diameter is twice the radius, we can write the relationship between the circumference of a circle and its radius like this. C, that's circumference. That is the circumference. The circumference is 2 pi r. So we didn't talk about this a lot, but the circumference is 2 pi. The circumference is diameter times pi. And we know that the diameter is 2 times the radius. Diameter is 2 times the radius. So the circumference is 2r pi, or 2 pi r. Finally, try the cool down. This cool down is not in your book, and it will be simpler than the problems that we did during the lesson. But the cool down states circle A has a diameter of 9 centimeters, circle B has a radius of 5 centimeters. Number 1, which circle has the larger circumference? And number 2, about how many centimeters larger is it? I encourage you to try this problem, because this problem is a little bit easier than the previous problems about the track and the picture frame. And this sums up the ideas that you need for this lesson. So pause the video and try the problem. So there's 2 circles here, circle A and circle B. Circle A has a diameter of 9 centimeters. So the diameter here is 9 centimeters. There's our diameter. And circle B has a radius of 5 centimeters. So circle B, the radius, here's the radius, is 5 centimeters. So which circle has a larger circumference? Well, if you find the radius and diameter of one, you can compare it to the other. So I'm gonna use this circle. I'm gonna use that circle, the one on the right. And if the radius is 5 centimeters, then the diameter is 10 centimeters. And if you compare it to the one on the left, that is larger diameter. So it's a larger diameter. Diameter is 10 centimeters. So we know that the one on the right has a larger circumference. It has a larger diameter and therefore a larger circumference. But the question now is about how many centimeters larger is it? So you can now calculate the circumference of each one. And the circumference of the one on the right, I'm going to use a different color. I'll use red. The circumference here is 10 pi. 10 pi. And the circumference on the left is 9 pi. 9 pi. So about how many centimeters larger is that? Well, this is about 9 times 3.14. Or you know what? I'm just going to say 3. Because we're saying approximately. So that's 18. And the circumference of the one on the left is 10 times 3. 10 times 3. Which is 30. So how many times larger is 30 than 18? 30 minus 18. Is 12. So the one on the right is approximately 12 centimeters larger than the one on the left.